Perfect. Thank you very much, Erica, for the introduction. Yes, this also works. Great. Thank you very much. Thank you very much, everyone, for coming here. Today, I am going to talk to you about sort of third-generation architectures and really this idea of moving from VMs to IAMs, or moving from virtual machines to intent machines. And I think this is sort of going to be the theme in, I expect, the next sort of 5 years or so, that along with this chain abstraction, we'll actually move away from directly building against virtual machines. We'll still use them as execution environments, but we'll very much move at the user and at the developer level towards intent machines, where users can specify their general intents and then specify the settlement conditions that they care about, and maybe those intents then get settled on Ethereum or they get settled on Near. The intent machines generally are agnostic to specific execution environments under the hood. So yeah, if you only take away one thing from this talk, it's Anoma is the universal intent machine. That's really the TLDR. If you've remembered this, you've remembered most of the talk. And now, so I'll start by going a little bit through historic evolutions of how we got to where we are today and sort of what the next generation will look like. So it all started with Bitcoin and transactions. And Bitcoin-like systems that were fundamentally transaction-centric. Yes, they had limited scripting capabilities, but that was about it. So you could start building sort of limited applications on it, but really you didn't have a full programmable environment that you could use. And there were many things like Bitcoin during that time. Sort of when you think Litecoin, Zcash, Monero, they all fall into this generation one of transaction-centric systems. From there, we moved to virtual machines, and all of a sudden, instead of having limited scripting capabilities, we now have, this is sort of the current world, we now have virtual machines and full programmability. And Ethereum and all other existing architectures really fall under this model. It doesn't matter whether it's Near, Solana, Avalanche, or Ethereum, they're all fundamentally virtual machine centric. As in, at the core of the system, a user interacts with a virtual machine in order to generate some state transitions. And generally, this takes the form of a user signs a transaction that gets executed by this virtual machine. And from there, we move towards, so the next move is going towards intents. And here, really, Anoma introduces the paradigm of intent-centric architecture, of generalized intent-centric architectures. And I'm highlighting it this way because it's important to understand that we've had, even though everyone, probably, according to some marketing documents, we're probably at generation 15 right now, on a fundamental technical architectural level, we had 3 generations. We had generation 1, Bitcoin and Bitcoin-like system that are transaction-centric. Generation 2, VMs and virtual machine-centric systems, Ethereum and Near and Solana and so on. And then generation 3 is going to be intent-centric systems where users don't necessarily interact with a specific blockchain, rather they interact with a high-level abstraction around intents on top of many different blockchains. So, Anoma is the first design for a universal generalized intent-centric architecture. It really follows along this idea that, actually, maybe to just clarify something here, many people talk about intents nowadays. And sort of the pessimists in the room will say, well, intents are just limit orders. And this is true. Limit orders are a very specialized kind of intent. A limit order is a super specific intent. This does not mean a limit order is a generalized intent. A general intent is the ability to execute arbitrary programs over arbitrary state changes, where a user simply defines, this is the state A that I currently have, and I'd like to be at state B, and here's my programmatic sort of authorization in order to transition this. And the important thing is you kind of dependencies here, that one intent depends on the state of the system on other intents. So for example, in a generalized intent system, I can say things like, if the weather is nice in Paris, I would like to participate in this Gitcoin DAO. And if the weather is nice in Seoul, I'd like to sell all my Bitcoin. right? Like you can do arbitrary complex dependencies here, but that are always written as I have currently state A, and I'd like to go to state B, and someone else can figure out the compute. This is actually the really fundamental abstraction that intends to describe state changes, not execution traces. And essentially in all the VM-centric models, users always describe execution traces, as in, I want to execute this opcode, that opcode, that opcode, and yes, it results in some specific other state, but the user didn't specify that future state. The user specified and signed over a specific execution trace, whereas in an intent-centric world, users sign over the specific end state, and then they don't care how to achieve this end state, because it may involve a bunch of ZK proving, it may involve a bunch of multi-chain hops. It doesn't matter to the user. The user just clearly defines, what do I have right now, what do I want to have in the future, and then other people, other parties in the ecosystem can figure out how to get them this. So as a little bit of a recap here, what is a VM? A VM is an instruction set, a program counter, many different layers of memory, and so on, that sequentially runs a program. A very good example, and probably the predominant example of virtual machines, is currently the Ethereum virtual machine. And this is really at the heart of Ethereum. The Ethereum virtual machine is what makes Ethereum work. Whereas, what is an intent machine? An intent machine takes a batch of intents and computes valid possible state transitions. Possibly selects one of them according to some defined criterion that can be encoded in the intents too. This is not encoded at the protocol level in the intent machine. This is rather encoded by users. And then executes and then updates the system state. For example, here, the only model, and I think we will see many different intent machines going forward, but so the first one that we're working on is called the Anoma resource machine. And again, here it's important to highlight that intent machines are not replacements for VMs. We're building on the shoulders of giants. Without VMs, we can't have intent machines. So we must always, Anoma is not designed as a replacement to existing systems. This is, if users want to use Ethereum, Anoma just provides a different layer of abstraction that is more general that users can interact with, rather than having to directly interact with the EVM or the SVM, for example. So yeah, from that perspective, Anoma is a new paradigm for infrastructure. And this has two components here, which is one, operators can decide to run many different nodes or many different subsets of nodes. So currently, an operator generally will run for example, an Ethereum full node, and maybe they also run a validator. With Anoma, operators may also still do that, but they can also run many different sidecars that enable this intent-centric paradigm. And yeah, this actually goes to the second point, which is, from a user perspective, everyone becomes a one out of one blockchain, essentially. Like when you think of a blockchain, Ethereum may have 100,000 validators, but I can build a blockchain that has just one validator, which is me. My phone is not a client that connects to some full node over an RPC call, right? Which is the current model. Really, we have full nodes that are running somewhere, and then users on their phones connect to those full nodes via RPC clients. But they're fundamentally architecturally different. Like a client is different than a full node. In Anoma, a client is just another node on the network. They just live on the same P2P stack, and they just expose different capabilities, which is really, really important when you think from a sort of, depending on the size of my phone or the powerfulness of my phone could decide to run many different softwares, right? If it's a very non-compute intensive, if it doesn't have a lot of compute power, it may just will try to read some intents and submit some intents. If it's a very beefy phone, it may decide to run a light client verifier. So but I can locally configure this on my node. I don't have to install different node software. This is just all the same node configured, all the same software configured with different runtime parameters effectively. For builders, you get the benefit that you get decentralized counterparty discovery and distributed solving, as well as a bunch of novel properties around information flow control. For example, for builders, an intent-centric model or the intent machine enables the capability that you can actually build fully decentralized rollups where there are many different solvers in the network or many different sequences in the network rather than a single sequencer. Whereas a user, you don't have to pick, but you can, for example, if you wanted to. And then here on information flow control, this relates to with intents, users can choose what data to reveal versus not to reveal. And this is not to say that this provides privacy. No, it just provides optionality to users that they can decide to reveal some data versus others. Whereas in a transaction-centric world, you really have to reveal everything. Yes, and then I'll briefly sort of mention this, which I think is very important in this move away from transactions towards intents, or away from signing over execution traces to signing over specific state changes. For my parents, it will always be impossible to verify an execution trace, as in they will sign over it because they sort of hope that it's correct, but they have no capability to ever, and I would assume this applies to 99.999% of all users, that they don't have the capability to verify execution traces. Whereas in this intent-centric world, by signing over specific state changes is much easier to verify because you don't have to care how sort of the compute happens, you just have to care what specific future state you're willing to accept. So, and with this, Anoma is a universal intent machine. It provides 4 key affordances. It provides permissionless intent infrastructure, intent-level composability, information flow control, as well as heterogeneous trust. I'll sort of go through them in the later half of this talk. But most importantly, Anoma is an intent machine for Ethereum. Builders can just write dApps, but instead of using transactions, they can use intents. And really what Anoma does here is it provides the intents, and then Ethereum provides the ordering, potentially the solving, and the settlement can happen elsewhere, right? It could happen on the Ethereum main chain, it could happen on Base, it can happen on many different rollups, and I'll come to this later. It can even happen on other non-EVM chains. This is fundamentally, we are making an architectural jump away from being very chain-specific to intents are general abstraction across many different execution environments. And as such, one of the big advantages of this kind of system is that it helps with the fragmentation between different security models and the execution models. Right, like if you're in a transaction-centric model, you have to pick which mempool you submit your thing to. You have to pick it either on Near or on Solana or on Ethereum. With an intent machine, you can say, well, I have an intent, and it could be either settled to Ethereum, or it could be settled to Near, or it could be settled to Anoma. The intents don't care. The intents are fully abstracted away from specific execution environments. Oh yeah, right. This is very important actually. Chris, my co-founder, just dropped a very nice talk, very nice blog post, sorry, not a talk, on ETH research. If you haven't read it since 3 hours ago, there have been updates, so please check it out. I'll also include the link towards the end. An important distinction I want to make here is that Anoma is an interface. It's not an intermediary. And I'm saying this specifically because I think a lot of people are starting to throw around this idea of intents, and really what they are building is intermediaries, people that are sort of actors on the network. And as a result, a lot of these actors can extract rent like MEV extraction. However, Anoma just provides a universal intent interface, and an interface is really a protocol which translates one semantic, for example, in this case, declarative intents, in terms of another. In this case, imperative ordering, compute, and storage. TCP/IP is a great example of this, that it's a protocol, it's an interface, it's not an intermediary. Anyone can use TCP/IP without having to go through the single server run by Oracle. IBC, to a large extent, is similar here, where IBC just provides an interface that you can use to encode network messages. You do not ever have to go via the Cosmos Hub in order to use IBC. And so I will leave this with this, that interfaces are simply code, whereas intermediaries are actors that can extract rent or add extra security assumptions, and that there's no Anoma-specific chain which you must send your intents to. You can use intents on the systems that you like. You never have to interact with any specific Anoma chain in order to do this. So, Anoma is an intent machine for Ethereum. And the EVM is amazing at execution and security. And Anoma simply provides something on top that wasn't there before. And this is generally true. You can see this later this is generally true across the case. Anoma just provides something on top. It doesn't try to replace Ethereum, Solana, or Near. It just provides extra utilities on top. And specifically, it provides intent level composability, intent machine composability. So not only do we have intent level composability, we have many different intents composable with each other, but also intent machine composability, where users don't have to specify the specific chain that they want to interact with, but rather this gets abstracted away from them and can be encoded in the intent. And so users can treat a network of many chains as if it was a single intent machine. It allows application portability so that my phone can essentially roam between different execution environments, different security domains, different concurrency domains, without having to download a new wallet. And Anoma provides permissionless intent infrastructure. Anoma is an intent machine for Solana, for Cosmos, and many more. Really, Anoma is an intent machine for your favorite execution environment / security domain. And I will say this also, that Anoma is also an intent machine for a proof of authority chain run by the Swiss government, for example. Like, the intent machine doesn't care about it. Whatever security models or execution environments people want to pick, Anoma supports it. Yes. Anoma is also scale-free. This is and I'll have to go a little bit more into what this actually means, which is that it provides both local as well as global scalability. There's not supposed to be just one instance of Anoma. This is very difficult, and we are all currently in this industry building a model where there's like one chain to rule them all. And we're all coordinating via this one central point, even if the central point is a decentralized chain. In Anoma, I'm my own Anoma chain. Like, I live in Switzerland, the city of Zug can run its own Anoma chain. This is what I mean by scale-free. At every single point where the trade-off space becomes, where users want to make the trade-off between latency and cost, they can decide to effectively run a smaller, more local instance. And if you come from trading, this will actually make a lot of sense to you, because latency constraints are fundamentally bound by speed of light. And if you want to have the fastest, cheapest execution, if 3 of you are in a room, it makes no sense to run via a server in New York. You should be trading and settling locally on your own local instance, rather than relying on a global security model. And so, by the way, this is just like a property of distributed systems and physics. This is not something that you can get beyond. Like, if we can have infrastructure where 3 of us in a room can just settle their trades directly locally, we can run over LAN or fiber optics. This will always be cheaper and faster than going via central servers, or central systems, even if these systems are decentralized, because you will never get better in terms of latency than 3 people in a room. Yes. A little bit on, and I touched on this on multi-chain atomic settlement. So with Anoma, you get this capability to have multi-chain atomic settlement. And what this effectively means is that you can have a homogeneous architecture, but with a heterogeneous security model. That different people will have different requirements in terms of what security model they care about. But you get a homogeneous intent machine abstraction so that people don't have to also change the applications that they want to use. And a very good example is international roaming of mobile phones. It'd be very stupid if I have to buy a new mobile with a new standard for every single country I go to, right? Like, one of the very nice benefits of mobile phones is nowadays that my phone roams across the world. And this is because we fundamentally have a homogeneous architecture for how cellular networks work in heterogeneous security models, because whenever I go to a new country, I'm entering a new security model. And this is the same abstraction that Anoma allows. And really here, the only limitation is Anoma is available wherever there's an Anoma protocol adapter. This could be Ethereum, an EVM rollup, a non-EVM rollup. This could be an Eigenlayer AVS. This could be Cosmos chain on Near, on Solana, you name it. Yes, this also comes to IBC2, which is effectively the ability to not only have async message passing between systems, but also have synchronous message passing between heterogeneous trust domains. And this comes a little bit, one can view this as a form of heterogeneous sharding, which I should go to in a sec. Okay, now in the last bit, I'd like to go to some very specific components of Anoma's architecture. And let's start with the P2P layer, the intent gossip layer. Anoma does a lot to abstract all the different parts of the stack apart from each other. So there's a specific P2P gossip layer. And the benefit here is that this node 35 may just be my end device, my phone, that is running light client verification. But I'm sitting on the same, and this way I can submit transactions and intents to the network. But I'm not sort of I'm not connecting over an RPC. We're all just nodes on the same network. And these domains represent essentially different blockchains, for example. So, for example, domain 1 could be Ethereum, domain 3 could be Solana, domain 2 could be Near. And all these nodes just gossip with each other and provide this capability. Okay, so coming to the actual consensus, and I'm sorry that this diagram looks very overwhelming and I won't spend nearly enough time going through this, but this is about Typhon and Chimera chains. And Chimera chains you can think of as a large extent as generalizing shared sequences, which means that you can use Anoma to, for example, settle things, or Espresso could use Anoma in order to settle things. So a shared sequencer like Espresso could be used to settle Anoma intents. And really here the basic intuition is that you can have many different chains that, if they so choose, can connect to each other and form synchronous shared blocks. So the things in the middle here, do I have a pointer? Like this part is effectively a new on-demand blockchain that is both synchronous with both chains. So you have chain blue and chain red, and you have a shared synchronous chain in the middle on demand. They don't exist all the time, only when users or developers actually want to pay for the execution cost of getting shared security and getting synchronicity. Again, all of this effectively, users can decide at what point the cost is worth it. And then coming to the last part is the Anoma resource machine. So everyone asks me, what account model does Anoma use, or what model does Anoma use? Is it an account model or is it a UTXO model? And the answer is it's neither. It's a resource model. It is sort of the best of both worlds, where accounts can have lots of complex state attached to them. And so we have resources in Anoma that have fully arbitrary state attached to them. This could be a fully fledged program plus a bunch of different keys in a database. But resources are only created and destroyed. So when I spend a resource, I create, and for example, my resource is a contract, I'm creating a new contract every time I spend this contract. And the important thing to remember here is that the Anoma resource machine unbundles 3 different components that in most existing systems are bundled together. It unbundles the state architecture, the instruction set, as well as the message passing model. So for example, in the EVM contains all 3. It contains the state architecture, the instruction set, as well as the message passing model. In Anoma, the Anoma resource machine only cares about the state architecture. And then different users, different actors can decide what kind of instruction set or what kind of message passing model they will actually want. And message passing model, for example, is mostly influenced by the actual topology of the network, which is not something we can ever write into an architectural diagram, because the topology of a network is defined at runtime by the actual behavior of real people. So with this, again, here's the link. If you haven't read the blog post, please do. Take like an hour or 2 to go through it. It also links to all the underlying research. So there's also the Anoma research topics at art.anoma.net, as well as the research forum at research.anoma.net. You can also follow us on Twitter. And that's it. Thank you very much.